part B.2, estimate the cost. We did part of the estimation work in the B.1. So now B.2, the remaining, the major part. All right. So let's continue our discussion. Yeah. To do, so what do we need to do here at this point? Count the number of multiplications. So this one, we need to do a little more work. So how much work? So let's take a look. First, we need to count the number of multiplications in each general term. This one. Okay. After that, another part, get a total, add up all these numbers. Okay. Not very hard, so let's do step by step. Yeah. First, the work part 1, yeah. How to get the number of multiplications. A sub k times x to the kth power. How many multiplications do we need? Yeah. So it's pretty simple. Yeah. Can you try yourself first, get a number, so then compare with my number. Yeah. All right. So here, although this question is pretty simple, but I like to introduce a special strategy here. General special strategy here. What's that? Try simple examples. When we have this situation, many times we use one special strategy. So this strategy, try simple examples. What do you mean that? Let me show you. All right, because k, we know k from 0, 1, 2 through n, right? Yeah. Based on our analysis in the previous video, we have this. K equals 0, that's trivial, right? No multiplication, that's trivial. So we do not need to try that. So let's start k equals 1. Then the term becomes a1 times x. How many multiplications? 1, right? Yeah, that's easy. 1 multiplication. Yeah. So let's try second. A sub 2 times x squared. How many multiplications? A squared, we need 1 multiplication, right? A2 times a squared, second multiplication. You can see this time the answer is 2. All right, let's try another one, the last one, okay? A3 times x cubed. How many multiplications? X cubed, we need 2 multiplications, right? X times x times x, 2 multiplications. Then another multiplication, a3 times x cubed, third one. So you can see after these 3 experiments, can you see some rule here? When the subscript equals 1, your answer is 1. When subscript is 2, your answer is 2. When subscript is 3, your answer is 3. Can you get the answer by induction? That's induction. Yeah. When the subscript is k, what is the answer here? Right? Yeah. The answer is pretty straightforward. K. Okay? K multiplications. Yeah. Then we need to do this. Add up all these numbers. So here I use this, table to do it. Yeah. So the first term answer 1, 2, 3, and so on through n, right? Then we add up all these n numbers. And then we know the formula, right? 1/2 times n times parenthesis n plus 1. That's the answer, okay? This many multiplications. Answer. In order to consider the addition part, multiplication part, adding together, we need to use the units of time, because in that way we can add up these two different operations, in terms of number of units, time units. Okay, yeah. So that one here, yeah, we know each multiplication uses 10 units of time, right? 10 units of time. Okay, based on that assumption. Yeah. Now the total units of time, addition part and times 1, because each addition takes 1 unit of time. But the number of multiplications should multiply 10 units of time. 1/2 times 10, that's 5. So we get a second term expression. Yeah. Adding together, we get this final expression. Right? Yeah. So we get the answer. Yeah. That's our estimate of cost. The cost here, we use units of time to represent the cost. Okay? Yeah. Computing cost. So we can treat as computing cost. All right. So next, how to reduce this number. Yeah. So you can see later when we work on more and more computing problems, this is pretty common. After we get a solution of one computing problem, we always ask ourselves, can we improve the efficiency? Yeah, that's the common question we should ask all the time. Yeah. All right, so here to answer this question, we apply some improvement strategy. So you can see in our problem solving, we use many strategies. Even in one problem, we use multiple strategies. Okay, just like playing chess game, we need to use many strategies. So here, yeah, we keep using different strategies. Yeah. All right, so here we make our observation first. What kind of observation? We want to find some special property. So we do some careful examination, okay? Try to find important property. So here we find this one, the cost ratio. Two operations, we will look at the ratio of their costs. Okay? Unit cost of multiplication over unit cost of addition. How much is that? 10:1 ratio. So that's a pretty big number. Okay? Yeah. From the ratio perspective, it's a pretty big number, 10:1 ratio, right? So this number tells us something pretty important for our strategy, because here we like to get some strategy first. Yeah. All right. So the conclusion is, yeah, focus on multiplications. So this is the strategy improvement, because when we focus on the multiplication part, we have more room to improve, right? More room, yeah, because this term is much larger than the first term, addition term, much larger. So we have more room for improvement. If you try very hard on addition part, you only have very little small room for improvement. Not worth your investment. Okay? Yeah, so this is another strategy. Yeah. Here, put your greatest effort in multiplication part. All right. So after we have this strategy, yeah, so let's clarify our strategy. Okay? Reduce the number of multiplications. So let's work on this direction. So this strategy gives us direction to go. Okay, all right. Next, implement the strategy. How to do it? How to get there? Yeah. So we look at this issue. Okay. All right. Strategy. Yeah. For this, the formula part, 2 terms. The second one much bigger than the first one, so we know we should work on the second term. Try to reduce as much as we can on the second term. Okay. All right. Strategy usually tells us direction to go. Yeah, we know. So we should work on the multiplication part. That's the direction to go. Yeah. Execution, also very important. It tells us how to get there. So we need this part. We need to figure out how to get there, how to implement this strategy. All right, so let's work more here. How to reduce the number of multiplications. Okay. All right. Another strategy. Yeah, so you can see every time when we have something relatively hard to work, we need some strategy. So here, we need another strategy. This time for implementation strategy. Okay, all right. Study a simpler case. We used that before, right? Try to experiment from simple cases. We try that. So when we calculate the general term ak times x to the k, we apply that similar strategy. So here, study a simpler case. You can see the same strategy, we use it many times. Yeah. All right, so here, let me show you the work here. Yeah. Consider n equals 2. Yeah. So it's a simple case, but it's non-trivial, so there is some interesting thing we can find. So we start from this simple case. P2 of x equals 3 terms, this polynomial adding together. So we call quadratic polynomial, right? So this is the quadratic polynomial. Okay? Yeah. When we work on this one, now, the first thing we like to do, try to find some important property. Then we can take advantage of this property to try to have some improvement. Can you see that here I combine the last 2 terms? Can you see something interesting here? Property, yeah. The interesting property, that's the common factor. These 2 terms have common factor x. Common factor x. Okay? So that could be useful, right? Could be useful, yeah. So here, let me introduce another commonly used method in problem solving. So that's transform the problem. We commonly use this way, transform the problem. Change the shape, change the format, change the structure of a problem, transform. Yeah. Here, when we change the structure, we hope we can get new outcome. New outcome. When you change the structure, you have a chance for some new outcome. How? Let me use this example to show you how. Okay? All right. Factorization. Because if you have common factor, you can do factorization. That's pretty easy, but that helps us transform the problem. So that's what we need to do. Okay. All right. a1x plus a2x squared, after we factorize common factor x, we get the second expression. Both expressions, they have the same value, but different structure, right? Different structures. Yeah, so we can take advantage of the structure difference here. Okay, let's do the counting. the number of multiplications in the first expression, 1 plus 2. The first term, 1 multiplication. Second term, 2 multiplications. Adding together, 3. Yeah. But if we look at the multiplication in the second expression, that's quite different. Yeah. Because the first multiplication is here, this red arrow sign here. The second one, a2 times x. And we only need to do these 2 multiplications. So the number is 2. We can see from 3 to 2. Same value in 2 different expressions, but the number of multiplications are different. See? Yep. New outcome, right? Yep. Here. This is the new outcome. After we change the structure, we get a new outcome. Okay? All right. So the conclusion. Here. The conclusion. When we do the factorization technique. Yeah. So this is a small technique. When we do it, we have some pretty good gain here. Reduce the counting number from 3 to 2. 1/3 improvement. 1/3 improvement. That's quite significant. Okay? But that's just for the n equals 2 case. When n is larger, can we do better improvement? Yeah. So here, our last question. Can we generalize this idea to the general n? Right? Yeah. So we leave this part to part C. Next class, part C. Yeah, because we need to do a lot of discussion. Yeah. For this part B, we only have 10-something minutes. So I need to do some exercise before we move to the next part C. Yeah. All right, so let me stop here. Yeah.